Every database model is supposed to specify how to manipulate it. These are the set of operations which are used to manipulate the database. For example, once you store something in the database, right, a table, now you will be interested in getting some information out of it, maybe a row, right, completely, or a column, right, or we might want to specify that we want to get some information by combining two tables, right? Then every data model is also supposed to provide us, along with the the way to store the data, the way to manipulate it. Okay, manipulate means it is, don't think that we are going to manipulate everything. We generally take two or more tables and then we produce a new table. That is called manipulation, and that new table may be the result, right? So now if you look at this relational model, so for this relational model, if you want to specify some queries, we have a special language, we can call it, or set of operations, we can call it. It is called as relational algebra. And we have even one more language or one more set of operations which is called as calculus, relational calculus also. So both are popular. But then coming to GATE, in GATE we have relational algebra is more important compared to relational calculus. So we shall discuss both of them anyway, but then the main focus will be on relational algebra for this part. Okay, so as we said that this relational algebra is nothing but a collection of operations. Let's see what are the operations which are allowed, and again we shall go into each operation one by one. So if you are not getting what this actually means, you could think of it this way. This is theoretical concept. What relational model is a theoretical concept. Similarly, these two languages are theoretical languages. They are not practical. And relational model is implemented as relational database, right? So relational database management systems are going to use relational this one, right? For example, Oracle. And they have a language called as SQL. Now SQL, this relational RDBMS is similar to relational model, or it is a practical implementation of this. Okay, if you have to understand it even better, you can think of this one as a conceptual design and this one as the real practice, right? This one can be like a algorithm and this one will be like a program. So this is implementation of this one, right? Similarly, in order to manipulate the tables, practical tables which we get in the actual database, we are going to use SQL, right? And that SQL is also implementation of these two. So SQL is actually derived from relational algebra and relational calculus. If you understand relational algebra well, it will be very easy to understand SQL, right? That is why we shall see relational algebra first, and then we can go to SQL. The main difference between relational algebra and relational calculus is relational algebra is a procedural language, which means it will say what we want and how to get it. Each step will be specified in relational algebra. But in relational calculus, it is just a declarative language, which means it will say what we want. It will not say how to get it. Okay, what I mean to say is, in relational algebra, if you have a table, right, or if you have two tables, and if you need some information, then relational algebra will say clearly, take these two tables and combine them in this manner, in this particular manner, and then apply this condition and all. Everything will be specified step by step. But if you look at this relational calculus, it will just say that I want so and so information, you get it however you want, right? Which means it is just declarative, it is procedural, right? And SQL has been derived by using both the concepts of relational algebra and relational calculus, right? So first now we shall focus on relational algebra. So relational algebra is going to have some operations. So the terminology is like this. Okay. So first we have something called as operations. Operations mean these are the smallest set of units of work that we can perform on any table relation. One is pi. Projection. So projection means if you have a table, if you have a table like this, projection is nothing but selecting the columns, which column you want to see, that is projection. I'll give you examples later, okay? And next one is selection. Selection means we take the rows, right? This is selection. So the select operation of SQL and the selection here both are very different. Okay, don't get confused. When we go there, it will be clear. For now, think that projection means we work with columns, selection means we work with rows. And then we have cross product. I'll again explain all these operations, right? Anyway, this is only introduction. If you don't understand here, just leave it now. Now what cross product is? Whenever we work on a relational algebra, anything, we generally work on one table and on one tuple, right? So at any time we can only examine one tuple. One tuple means one row of a table, and sometimes our requirement will be in such a way that we might have to examine this tuple and we might have to combine or compare some attributes with the other table's other tuple. Now, in order to do this, only way it is possible to do it is by using cross product. So cross product is an operation which is used to combine two tables, right? And then by doing cross product, we can actually work on more than one tuple at the same time. Are you getting this? In general, we can work on only one tuple in a table, but if you have to work on more than one tuple at the same time, it is better you cross product them and you can work on them simultaneously, right? At the same time, you can work on more than one tuples which are from different tables, or you can even work on the same table also more than one tuple. So whenever you want to work on more than one tuple, you should always go with cross product. Either the those tuples can be from the same table or from the different table. And you know this set operation, union, right? So union is what? Taking the union of two tables, and you know that every relation is nothing but a set of tuples. Why set? They are all distinct, and the order does not matter. And the union of two relations is same as union of two sets. And set difference minus or set difference. So this one you already know. Set difference is nothing but when you have two sets, you take the difference, right? The same thing. If you have two sets A, B, right? If I write A minus B, then it should be in A and not in B. This is the part, right? This is set difference. And next one is rename. Rename is used to change the name of the attributes or change the name of the relations. I'll give you examples how it is done, right? So we have something called as expressions. Relational algebra expressions. So expressions are nothing but they are formed by a sequence of relational algebra operations. Okay, don't get confused. Operations are the basic elements, and from operations we combine them and we get the expression. Just like in mathematics also we have plus, minus, star like this, and we get the expression from them, right? Similarly, we have operations, and from these operations we can form the expressions. So expression is sequence. We can consider it as a sequence of operations, right? So sometimes what happens is some relational expressions are so popular that we even use some symbols to write it in shortcut. Some relational expressions are used very popularly. See, these are the basics. From these basics, we derive some expressions, and out of these expressions, some expressions are very popular, right? So, for example, the expressions very popular are intersection. So, intersection can be applied, or intersection can be derived like this. If I want A intersection B, this part, right? So you can write it using these basic operations this way: A minus B. check this. So a minus b is, this part, isn't it? And a minus is, you are removing from a this part, then what will be remaining? This one, right? So a minus b is a intersection b, isn't it? And we have something called as join. It is very, very important. We had to spend a lot of time on join itself. Join. So this join is nothing but we take the cross product on some tables, and on the resulting table we select some of the rows. This is join, right? So I'll discuss about it again anyway, but why is it so important is, whenever we combine two tables, we don't randomly combine any two tables. We combine them only if they are related some way, and whenever they are related, we take that relation into the picture. Are you following this? What I mean to say is, we generally don't combine the tables randomly. We combine them whenever they have some meaningful, relation between them. For example, if you have employee, right, and if you have dependent, we have employee table and we have dependent table, right? And we are going to combine them in such a way that whenever we combine these two tables, we don't want to see some employee and some dependent. We want to take an employee and maybe all the dependents who are depending on this particular employee, right? We don't want to combine everything here with everything here, isn't it? Therefore, we have to even see who are the dependents on which employee, or who are all the dependents on a particular employee. So in order to write such meaningful queries, it is meaningful to use join rather than just the cross product. So join is derived from the cross product. We shall again see this with examples, okay? So these are very popular that they have been given some name also, right? And then there is one more operation, division. We shall see this using examples, okay? How does this division work? How does this intersection work? And how does this one work? But then anyway, these are the basic operations from which these are derived as the expressions. These expressions are actually named because they are very popular. Okay, so let's see one by one, and then we shall examine some questions on that. It will be very easy. So this part of database DBMS is very, very scoring. This relational algebra especially, and compared to relational algebra, these two languages, relational algebra is having 80% weightage and this one has a very less weightage. So we shall focus first on this. Okay?